Well, in our previous classes, we have seen that quantities, physical quantities, those who are having direction as well as magnitudes, and those who are abiding by the vector law of addition, we classify those physical quantities as vectors. Now, before applying the concept of vectors to different areas of physics, we will classify these vectors into different categories. To start with the equal vectors. What is equal vectors? Equal itself justifies that the magnitude as well as the direction of the vector are same. Supposing you take two vectors A and B, then both the A and B vectors are said to be equal if the direction of both the vectors are same and their magnitude are also same. So in this case, here A and B vectors are said to be equal vectors if their magnitude and the directions are same. Now in case of a negative vector, coming to negative vectors, vector A and B are said to be negative vector of each other if again their magnitudes are same but only their directions are opposites. They are opposite to each other. So in that case, we will just change the directions like this. So A and B are said to be negative vector of each other when their magnitudes are same but they are opposite to each other. In case of a co-initial vectors, now let us see what is a co-initial vectors. Co-initial vectors are those vectors who starts from the same point, from their initial point being same, they are called as co-initial vectors. So if O being the starting point for both these vectors, then vector A and B are said to be co-initial. They are starting from the same point. And unit vectors, what is a unit vectors? More importantly, unit vectors are those vectors whose magnitudes are unit. And unit vectors is dimensionless. It has no dimensions and no unit. It only carries the magnitudes. Supposing A is the vector, then A cap, we write A cap as the unit vectors. So here your A being a vector, the corresponding unit vector of A vector is represented and termed as A cap, who is written as A vector upon the magnitude of the corresponding A vectors. And more importantly, these unit vectors possesses the direction of the original vectors and its magnitude is 1. So you can imagine the unit orthogonal vectors. What is unit orthogonal vectors? So here, supposing x and y, this is z. So I cap, j cap, k cap. Orthogonal means they are mutually perpendicular to each other. If you carry two vectors, supposing instead of taking this vector is coming out, z vector, my z vector here, z direction is coming out of the blackboards, right? So to pick up, we can first take a two dimensions. In case of a 2D, we have, let us say, x and y. You have I cap, you have j cap. So this is actually a planar vectors. Here, all the discussions which I have shown in two axes having 2D mentioning, in that case they are called planar vectors. They lies on the same plane and my plane is the plane of the board where I am explaining. Now in case I have a three dimensions where my another dimensions or z axis is coming out of the blackboard perpendicular to the blackboard towards u. In that case, another unit vector k cap I can define, which I can say is unit vectors. So these I, j, k are called unit orthogonal vectors along the respective x, y, z axes. Now coming to collinear vectors. What is collinear vectors? Collinear vectors are those where they lies on the same line. You say same line. Collinear. They lies on the same line. They are called collinear vectors, and collinear vectors can be parallel, they can be antiparallel. For example, here if I take three vectors like this, so here these vectors, if I take, these are antiparallel vectors. I can say these are antiparallel vectors which are collinear, and all these vectors, three vectors, are collinear in nature. Similarly, I can say these vectors, if I say these two vectors are parallel vectors, they are called parallel vectors. Now non-collinear vectors, any vectors those who are not linear, suppose this is one vector, this is another vector, so in that case these two vectors, which I can say as planar vectors, because they are lying on the same plane, I can say they are coplanar vectors, but certainly they are not collinear vectors. So I say they are non-linear vectors, and they are line functions, they intersect at some point. I can say that non-linear vectors, they intersect at some point when extended. Now coming to coplanar vectors, all those vectors which I can draw on the board are called coplanar vectors. Vectors those who are lying on same plane, we can say it's coplanar vectors. Now coming to null vectors. A null vectors is a zero vectors. I can say null vector is a zero vectors. Okay, I can write it like this way. Null vector doesn't possess any dimensions. It takes the dimension of the original vector. Supposing, what is the advantages of the null vector? It always balances the equations. For example, you have two vectors a and b, which may be after subtraction or addition giving rise to null vector. So you can write down, so in that case a vector plus b vector may be giving rise to zero vectors or null vectors. So here I can say then b vector is an antiparallel vector to the, or b vector I can say is a negative vector of a. So in that case here I can say that is the b vector is a negative and vice versa. Now coming to the position and displacement vector to start with. What is position vector and displacement vectors? Supposing you have here is the origin O, the body is here P. Then when we consider a point P, the body is lying at a point P1, we refer to certain origin and say OP1, or which I say R1 vector is the position vector of the particle or the body with respect to origin O. Now that vector R vector is called the position vector of the particle. Similarly, if the particle which is lying at P1, it is displaced to another point, let us say P2, then I can draw another point here R2, then I say the R2 being the final position or the P2 being the final position, R2 is the another position vectors or the final position vectors, then I can say that this one, that is P1, P2 is the displacement vectors. P1, P2 being the displacement vector, which I can say that is R2 vector minus R1 vector. That I say R1 vectors. So like this, we classify different vectors. For our further discussions, we will proceed about more discussion regarding these classes in subsequent classes. Thank you.